Ching Shu, or Shu Ching, depending on what part of the world you're in.
Yes.
And he's been my grad student for what, 2.5 years now?
Almost, yes, 2.5.
Yeah, 2.5 years. And has worked very hard attempting to be the first person to artificially inseminate the insect Drosophila melanogaster.
Thank you everyone to come in my teacher's defense. My name is Ching Shu, and my lecturer is Dr. Charlie Hurd, and my topic is difficulty of implementing artificial intelligence technology to Drosophila melanogaster. First, I want to introduce my outline. The first is I want to talk about the importance of the Drosophila melanogaster in the artificial insemination of insect species and the application of insemination and the function of the seminal fluid protein and the use of trypsin and the trimethophosphate. And next, I will talk about the material and the production of virgin female and the collection of semen, collection of the and the injection of the SC gram, and the production of TMB sperm male, and then finally I will talk about artificial insemination. And next is I want to talk about my experiment design. I have total 7 different experiments. I will describe the detail later, and next I'll talk about result in the discussion. The first, the introduction, I want to talk about the importance of Drosophila melanogaster. Drosophila melanogaster is one of the most studied organisms in the genetics and the embryology. And the first time the Drosophila melanogaster was being used for the genetics was by Thomas Morgan in 1910 for heredities. So there are some reasons why Drosophila melanogaster is so important, because they are small and easy to culture in the laboratory. They have very short generation time, just 10 to 12 days, and they can produce many offspring. For example, one female can bake 100 eggs per day, and in her lifetime they can produce maybe 1,200 eggs. And the Drosophila melanogaster is sexual dimorphic, so they're easy to separate the male and female. And in the genetics analysis, the Drosophila melanogaster they can use to the genetics transformation technique, and also can all the complete genus of the Drosophila melanogaster was be sequenced in 2000. So that's because the importance of the Drosophila melanogaster keep them alive. It keep the strain alive very important too. So there are right now more than 30,000 different strains already maintained in the stock center, and each year they have new strain. 6,000 new strains have been discovered every year. So this stock center needs to change the media every 2 weeks. So therefore, the cost of the material, labor, and space is considerable. Therefore, it's a clear need to store cryogenetics, the strain of the Drosophila melanogaster. In our lab, recently already success about the cryopreservation of the honeybee apis mellifera. So therefore, we can use this kind of technique to the Drosophila. But first, we need to develop artificial insemination of Drosophila melanogaster. Next, I want to talk about the artificial insemination of insect species. In the animal hospital, artificial insemination is widely used for the animal breeding, such as the cat, sheep, or the pig. But in the invertebrate, there are only 2 successful artificial insemination in the insect species. The first is the honeybee apis mellifera, and the second is the silverwort bouncy murray. In the case of the honeybee, artificial insemination technique already successfully developed for breeding queen for maintain the honeybee colonies. And this kind of the honeybee, they can lay the eggs for several years after just one insemination. So we can adopt the honeybee, the artificial insemination technique to the Drosophila melanogaster. So next, I want to talk about the application of the artificial insemination. Artificial insemination is kind of function to the develop other important techniques, such as the cryopreservation of the mutant strain of insect. There are 2 main reasons why we need to develop the artificial insemination of Drosophila melanogaster. The first is to store the semen over a long period of time, because the successful to store the semen can help to secure the strain have very important mutant. And the second reason is to advance transgenetic technology. Transgenetic technology is we can use the DNA induced into the target organism. For example, we can mix semen and we the DNA with the cryoprotect the DMSO, because the DMSO can help the cell to protect the semen from ice during the freezing, and that also can help the sperm to take the DNA into the egg. So this kind of technology already used in the honeybee. So this is very helpful to application the artificial insemination. Next, I want to talk about the function of the seminal fluid protein. In the case of the Drosophila melanogaster, copulation already induced a series of change in the female's physiology. This kind of change is because caused by the seminal fluid protein from the male from the male transfer to female along the sperm during the copulation. So this kind of protein we call ACPase. This ACPase is synthesized from the male organism called axis gland. So this photo shows the axis gland. This pair of the white small grain is axis gland. So this is tested. So they already have 112 different ACP already identified in the Drosophila melanogaster. There are three very important to the female reproduction. The first is the sex peptide, it's ACP70. So this kind of state they can help the female to lay egg, and they can also increase the female have sexual receptivity. And the next one is the ovulin. Ovulin also can stimulate the female to ovulation. And the next one is the ACP36D. So this kind of protein can help the sperm storage and transfer into the spermatozoa. So next I want to talk about the use of trypsin. Trypsin already found they have an effect to induce a high spermatozoa motility. In the Drosophila melanogaster, in the silkworm bouncy mora, if the spermacida will treat with trypsin, they can have improve the motility. And they also find after treated with trypsin, the silicon will be stimulated to lay the egg. So therefore, we will use the trypsin to mix with the semen from the Drosophila melanogaster, so to improve the sperm motility. Next, I want to talk about the use of trimethyl-phosphate. In 1968, the TMB already showed they have the sterilizing effect in the rodent. And in Drosophila melanogaster, if the larva of the Drosophila melanogaster will be treated with the TMP, so the eclosion adult will have show the sterility. So therefore, in order to get the semen fluid include this fluid from the axis gland into the female without any sperm, we will use the TMP sterile male to mate with the virgin female with insemination. So next I want to talk about the material and the method. To do the whole experiment, first we need to produce the virgin female. The Drosophila melanogaster will be reared in the bottom, have the Drosophila media, and the incubator and the standard room temperature, and have 12-hour photoperiod. So in Drosophila life cycle, the first 8 to 10 days is the embryo and the larval stage, and the next 6 days for the pupa stage. So in order to get the pupa, after 8 days of oviposition, the pupa will allow pupa in the wall of the bottom will be collected using the forceps. So the pupa will be collected individually into the 96 well. Like this 96 well, each well will have one pupa. After collect each one, we will cover with practice web to avoid the escape. So after the post-eclosion, this virgin female will be observed for the female identification. So this photo shows the difference in the female and the male abdomen. Like the right one is the male Drosophila melanogaster. In the end of the abdomen, they have very black and dark bristle. So it's very easy for us to separate the male and female. So next, I want to talk about to collect the semen. We use the two different ways to collect semen. Firstly, to collect semen is from the male virgin female. So first, we will put one female and 5 to 6 another mature male together. So the copulation will continue maybe 20 minutes. So after 20 minutes, the already made virgin female will be immediately separate and dissect use the fine needle. So because if the copulation just finished, so after we dissect the abdomen of the female, we can find the spermatophore in the uterus, like this black spot. So this kind of spermatophore will separate from the uterus and collect using the glass pipette. This glass pipette will pour and create to the opening is just 300 micrometer because it's maybe fit with the spermatophore. So it's the spermatophore and the spermatophore is the pipette. So next way to collect the semen, we collect semen from the mature male because in order to get the material, the semen from mature male, so we will dissect the dorsal side of the male. So the seminal vehicle will be removed from the male. So because they allow the semen inside the seminal vehicle, so after we pour, we pierce a little hole in the seminal vehicle, the larger of the sperm will visually come out, flow out. So we will use this pipette to collect the spermatheca, seminal vehicle, and the semen into this capital tubing. So the opening of this pipette is around 100 micrometer. So next one, I'll talk about the collection and the injection of the acidic grain. So in order to get the acidic grain, the pair of the acidic grain will be delicate cut. So this pair white, the grain will be the acidic grain. So we will collect about as many as 196 acidic grain and collect and stuck into this kind of glass tube. So this kind of glass tube, the volume is about 8 microliter. So after the acidic grain will suck into the tube, we will plug this tube into the liquid nitrogen and dissolve for the total 6 times. So after this procedure, the membrane of the acidic grain will lyse. So this capital tube contains the lyse acidic grain will generate centrifuge. So for the injection of the acidic grain, the virgin female first will be attached to the plastic pipette tip. So this kind of injection tip will create to the tip diameter of 15 micrometer. So this pipette will suck the acidic grain fluid and inject into the thorax of the virgin female. Next, I want to talk about how to produce the TMB sterile male. The Drosophila melanogaster will rear in the bottom have the Drosophila media and the 24 microliter TMB at the 0.005 milli concentrate. So this bottle will be incubated at standard room temperature, and after eclosion, and the 2 to 3 days of the sterile male will be tested and tested sterility. So next, I want to talk about the artificial insemination. They have the glass pipette will be modified to fit the abdomen of the female because we need to let the female abdomen will protrude from this tube. So this tube in the end will collect the supply of the CO2 was administered for next dilation. So there is a forceps was used to hold the virgin female, and another function is to squeeze the end of the female abdomen. So the pipette contains the semen will attach to this micromolecule, and this micromolecule can provide the pipette moving through the gonopore into the bouncing computer-electric of the virgin female. So after the abdomen will protrude from the female, so the female will squeeze the end of the abdomen, and the virgin female gonopore of the virgin female will open and was invert. See the difference before squeeze and after. So after the gonopore is opening and the glass pipette that containing the semen and the seminal vehicle will introduce through the gonopore into the processing calculation. There is a video about the artificial insemination. The Taipei will introduce into the example of the virgin female Drosophila melanogaster, and there the semen will come in to show we inject the semen into her gonapole to the bouncing calculation. Next, I want to talk about the experience design. The first experience is we want to test the effect of the carbon dioxide on egg production of virgin female Drosophila melanogaster. Because in honeybee, already found that the CO2 can stimulate the virgin female to lay egg. So therefore, the 3 to 4 days old virgin female will place in the 24 well plate each by each. So after the 24 well will set up, so we will treat with the CO2. We have 3 different treatments. One is untreated with CO2. The second one is treated CO2 one time, 24 hours after we transfer to the well. And the third treatment is we treat the CO2 two times, 24 and 48 hours after the transfer to the well plant. So the experience 2 is the insemination of the virgin female with the semen from male virgin female. So this test we just want to test if the simply insemination the semen from the male virgin female can have the successful result. So next, the third experience is the effect of the excess grain. We want to test if we inject the excess grain into the virgin female, if they can stimulate virgin female to lay egg. So next experience 4 is we combine the method about the injection excess grain and the artificial insemination with the semen from the male. So we will to observe if they will lay egg or not. So it purifies the insemination of virgin wingless female Drosophila melanogaster with the semen from the winged male prior to mating with the wingless male. Because the winged fly is the trait is dominant with the wingless, the trait is recessive. So therefore, we hypothesize that the wingless male will provide the required signal necessary for the successful mating. So therefore, if we can find the fly will appear among the progeny, so we can get the successful result. So the next experience 6 is the insemination of virgin wingless female with the semen from winged male prior to mating with TMP sterile male. Because we hypothesize that the sterile male can will program the insemination female to produce egg or transfer the semen or make the product to prevent the expel of the semen we ingest. So therefore, we will use the TMP sterile male to mate with the virgin female with insemination. So the final experience 7 is we will mix with the trypsin with the semen, and then to see if the trypsin can help the sperm motility or the female to lay egg. And the status analysis, I used a small sample the statistics to investigate if they have a different significance between in egg length between the three insemination virgin female or just the compare with the control group. First, I want to show the result in the experience 1. This is the total. This table contains the number of the total number of the egg leg and the average number of egg legs per female Drosophila melanogaster per day. We have 3 different treatments, but all treatment the female didn't lay any egg during the day 1 to day 3. They start to lay egg from day 4. But after the status analysis, we cannot find they have the statistic. If we cannot find they have the the difference between the treatment treat the CO2 or not. P-value is more than the 0.05. The next table shows the percentage of the insemination virgin female produce one or more larvae. In this experience, we total insemination 93. The virgin female used the semen from male virgin female. So we got 2 female to like the 1 or 2 larvae. So the percentage is 2.1%. In the control group, we didn't get any larvae. So next table shows the number of the larvae and alpha produced from the 2 successful insemination. The first one, they produce 40 larvae, and the 35 become the adult fry after eclosion. The next one, they have 1 larva and become the adult fry. However, after the static analysis, we cannot get a significant difference in the larva production between the treatment insemination virgin female or the virgin female, the control group. The experience 3 is we show the number of the female and the percentage of the virgin female products after injection as a screen fluid. So we total inject 39 the virgin female with acid green fluid. They all they can lay egg from day 1 to day 4, but they, in the untreated virgin female, they cannot egg until day 4. So next table shows the total number the egg they egg from the day 1 to day 4. So this shows the average number of egg laid per female. So after the static analysis, we find out that on day 1 and day 2, they are significant different in egg laid after we inject the acid grain or not. In the experiment 4, this table shows the number of and the percentage of the virgin female that produce egg and the larva after injection as grain and then insemination with semen. This time we inject as grain into the virgin female and then insemination with the semen from the male. We have 25 female. And even though they all can lay egg, but we cannot find any larva produced from this experience. So after the static analysis, we cannot find any significant difference in larva production between the injected acid grain and not. And this one is also show the number of the percentage of the virgin female produced after insemination with the semen first and then inject the acid grain. This results show that even though they still can lay egg, but they also cannot produce any larva. So after the static analysis, they also show the p-value more than 0.05 to be no significant difference after insemination and the injection acid grain with the control group. The experience 5 shows the percentage of the virgin female, winner's female, and the winner's male after insemination with the semen from the female primate to mating with the winner's male. Even though both of these treatment can lack the winner's fly, but they cannot win the winner's fly. So this means they don't have artificial insemination successfully. So after static analysis, the p-value is also more than 0.05. There is no significant difference between these 2 treatments. So the next experience 6 is the percentage of virgin female, winner's female produce egg and the wing fry after insemination with semen collected from the windmill prior to mating with TMP sterile winner's male. So even though we can get the 2 number of female like egg from the treatment, use the insemination, use the semen from windmill and the mating with TMP sterile male, but we all cannot get any wings fry in both treatment. So next, this table shows the 2 female leg, the egg, one is leg A egg and another 2 leg A 27 eggs, but they are all now will become the adult fry. So this means they are still male. They are still unfertile egg. Therefore, after the status analysis, the p-value is bigger than more than 0.05. So there are no significant difference after treat with the TMP sterile male or not. So the next experience show the percentage of Drosophila melanogaster proteins A and the wing fly after insemination semen treated with trypsin. So in this table, even we can get 2 number of the female leg A, but we also cannot get any treatment that can produce wing flies. Therefore, after the status analysis, we cannot find anything different from between the female treated with trypsin or not. Next, I want to go to the discussion. In this study, we attempt to build a system to solve the problem of the how to artificial insemination of Drosophila melanogaster. And in the first opinion, in the CO2 exposure opinion, there are no significance between the exposed CO2 or not. In the honeybee, CO2 is effect to stimulate to leg A, but there are one reason why Drosophila melanogaster we cannot find different. Maybe it's the duration of the development stage between the honeybee and the Drosophila melanogaster. So maybe the Drosophila melanogaster needs more different exposure time. So in the next experiment, semen from the male versus female, we did this experiment because we think that the semen from the male versus female may contain the acidic grain peptide that is necessary to program the female reproductivity. So, but with all, the result cannot get any repeat successful. So therefore, it's interesting to know because the honeybee they don't require the sexual peptide for the successful breeding outcome. So maybe this is one reason why the artificial insemination of honeybee is more easier and possible. And the next experience is inject an acid grain into the virgin female. We did this experiment because we attempt to program, because we inject acid grain is attempt to program the Drosophila melanogaster female in a way that is similar to what occurs from the copulation. In this experiment, we got successful result because all the female they can leg A during the day 1 to day 4. So we can prove that after ingest acid grain, so in excess grain fluid can stimulate Drosophila melanogaster to leg A. So the next experiment we combine the method of inject acid grain with the method of the artificial insemination. In this experiment, we also cannot get the successful result. The one reason is because maybe the female will expel the injection substance shortly after the introduction into her boxy copulation. So next experiment we try to match with the witness male or the TMP sterile male to prevent this kind of the result. The female expel the substance we inject. But this event also show we cannot get any successful outcome. So therefore, maybe before the inseminated virgin female met with the TMP over the sterile male, maybe they already expelled the substance we inject into her reproductive tract. So next is the trypsin experience. We also cannot find any trypsin can help the sperm to improve their motility. And in addition, after we put the semen and the triple with the trypsin, after we observe, we cannot find the sperm become more activity after mixed with the trypsin. So in the conclusion, in all the studies, there is no repeatable method to artificial insemination of Drosophila melanogaster. The main reason we believe is the female will expel any injection substance from her body copulation. So if we can develop a method to prevent the female from expel inject substance from the long periods to make like kind of the natural blood to avoid he expel the substance. So maybe we can conjunction with the injection of the acid grain. So maybe the path to successful artificial insemination of Drosophila melanogaster. With my bibliography and my acknowledgement, I think my advisor, Dr. Charlie Hurd, for her perspective and the patient and fix my grammar, anything, and give me the patient because of my English problem. And I also thank my lab partner Philip Baker. He worked with me every day to find out how to collect semen, how to inseminate artificial insemination, and how to collect the excess grain, because 196 excess grain is we need to spend all day to collect. So I very appreciate about that. And I also thank Brandon Hopkins to share the information about how to artificial insemination of honeybee. And I also thank Sandra to help me to collect the pupa. And I also say every time I have a problem in the laboratory, I can help him or Philip. So I thank everyone in the CANBE and my professor in my company. So thank you for the question. This is my daughter, this is my favorite.
All right. All right. Any questions?
Question. How long did you leave the pipette
How long?
inserted in the female when you injected the semen?
We
Was it
just introduced into her like the video show.
Uh-huh.
After we introduce the semen into her, we'll put out immediately after the sperm into the female. But we need to pull it out very carefully because sometimes the sperm is very long, it will maybe attach to the tip of the pipette. So we should be very careful.
I'm just wondering if you had left this pipette in longer period, because the copulation period is 10 to 20 minutes. If that might have increased your chance for success.
Yeah, but if we put it in longer, maybe we'll kill her or because in the beginning we do this experience, I try very deep and sometimes little longer, but maybe this will kill the female.
But if you left it in maybe 5 minutes,
5 minutes?
instead of, not put it in deeper, but,
Okay.
left it there longer,
So
gave her time
maybe put longer can stimulate to like egg.
to maybe create a plug
Oh, like bro.
that would keep her from ejecting the material.
Okay.
I'm just wondering if that might be something to consider.
Okay. Okay, it's good to
So,
try.
Because, it sounds like it was just kind of, you had a lot of flies to work with, so it was just, get it done as far as possible, but that might be something to consider, but you're really increasing the time period it takes to do this. So it's-
Yeah. Good to try.
I'm sorry, I don't have hardly anything because we talk all the time.
Okay.